Good day to you all. We are the Group 4 and today we'll be presenting our science topic, which is about collisions. For our objectives, our first objective is to observe what happens when two objects collide, and then classify those types of collisions based on what we see. Did they bounce off or did they stick together? Our second objective connects what we've observed to the real world. For example, how vehicle bumpers crumple to absorb impact or how football players brace for hits. These are some of the real-life examples of collision types we're testing. On to the materials we're going to use. Here are two dynamic carts, which serve as the colliding bodies in our setup. A digital scale to measure the mass of each cart, a meter stick to measure the distance traveled by the carts before and after the collisions, a stopwatch to record the time it took the carts to travel those distances, and clay, which is used to simulate inelastic collisions where the carts stick together upon impact. Okay, now let's move on to our theory and discussion. Collisions are all around us. It happens in everyday life, from sports to car accidents to the motion of particles. And these are classified into two types, which are elastic and inelastic collisions. During elastic collision, momentum and kinetic energy are conserved. They basically bounce off each other and retain their original shapes. In inelastic collisions, two objects collide and move as one object. Momentum is conserved while kinetic energy is lost, either it being transformed into heat, sound, or deformation. While in this experiment, we are not calculating forces or energy, though we are observing and then measuring the change in motion, such as speed before and after collision. Now let's move on to our procedures. Observing elastic collisions. Measure the mass of each cart using the digital scale. Cart A will be the heavier cart. Second, place cart B at rest at the center of the track. Third, push cart A towards cart B and let them collide. Fourth, for cart A, using a stopwatch, time from the start of pushing the cart to the time of collision. Then, instantaneously, time from the collision to the time of rest. Fifth, observe whether the carts bounce apart and record your observations. 6. Measure the time it takes for each cart to travel a certain distance before and after the collision to estimate speeds. 7th. Record the data to Table A. Observing inelastic collisions. First, attach clay to each of the carts. Second, measure the weight of each cart using the digital scale. Cart A will be the heavier cart. Third, place cart B at rest at the center of the track. Fourth, push cart A to collide with cart B. The clay needs to be facing each other. Fifth, observe whether the carts stick together or move as one object after impact. 6. Measure the time it takes for the combined objects to travel a certain distance after the collision. 7th. Record the data to table B. And onto our data table. For data table A, we mainly need to find the speed of cart A before and after collision, and the speed of cart B after collision. Then observe their behavior. Time before the collision is just time of collision minus the time of when cart A was pushed. For the initial speed of cart A, we need the time before the collision and then the distance. For cart A's final speed, we need the time, which is time of rest minus the time of the collision. And then get the distance. For cart B's final speed, just input the distance it has traveled and its time. After that, place the data to the table and repeat for the rest of the trials. After the necessary calculations are done, data table A should look like this. Data table B is more or less similar to data table A. In here, we essentially need to find the initial speed of cart A before the collision, and then the combined speed of cart A and cart B after the collision. When you're finished calculating the trials, table B should look like this. This experiment has given us an understanding of how collisions work. Although we didn't account for the collision formulas and calculations of other forces, despite that, it is clear that we confirmed the theory of collisions, where elastic collisions result in bouncing and inelastic ones cause the objects to stick. Through careful observation of how the carts behave before and after impact, we were able to visually demonstrate the principles behind this type of collisions. This hands-on approach made the abstract concept easier to grasp.